Today we're going to solve rational equations with radicals. And we're going to skip that. You are going to see two types of equations today. You're going to see the first type, in which you have one radical on the side and it's equal to a number. And then you're going to have some in which there's two radicals, and they're either going to be on the same side and it's equal to 0, or they're going to be on opposite sides. And then next time we'll do where we have two radicals with something other than a 0. So the top two is what we're focusing on today. And how you're going to do this is really in two steps. You're going to isolate the radical first, or radicals, and then you're going to remove them by squaring both sides. So this first one, you would isolate the radical. You can see it's already by itself. It's the only thing on that side. So you would then take and square both sides like this. The second one, you would isolate both radicals, so you can see this form is correct because both radicals are isolated, and then you would square both sides like this to remove the radicals. So here's our first problem. You are going to notice that both radicals have already been isolated. This one is by itself, and this one right here is by itself. So you can now remove them by squaring both sides. When you square both sides, remember the square root and the squared undo itself, just like if you had addition and subtraction. If you add 2 and subtract 2, they undo themselves. So what's going to happen is you're left with x minus 8, and then you're left with 20 minus x on this side. And then you're simply going to solve for x. So because I have only one x, I'm going to add the x to both sides here. That's going to give me 2x. I'm going to add the 8 to both sides. That's going to be equal to 28. When I take and divide both sides by 2, I get an answer of x equals 14. And here's the check. It says check for extraneous solutions. So extraneous solutions, you do have to plug in your answer of 14 to replace both the x's and make sure the left and the right equal the same. So what we have is we have 14 minus 8 on this side under radical, and here we have the square root of 20 minus 14. And you could see both sides give us the square root of 6. So you know you have the correct answer. All right, the next one, you're going to see the radical, again, has already been isolated. I think they're isolated on all of these, but they won't be on your assignment. And then that is, so we're going to simply square both sides to remove the radicals. So now this radical is gone because that undoes itself. So we're left with this. And on this side, we have an x squared. And I will tell you right now, every time you introduce an x squared, you will obviously get two solutions because of the squared. And that is where you really have to check for extraneous solutions, because typically one of them will be an extraneous solution. So back to solving this, because we have an x squared and an x, we have to get one of the sides equal to 0. So we'll have to take, remember I want to keep that positive, the leading coefficient. So I'm going to add the x, subtract the 56, and I get x squared plus x minus 56, and that is equal to 0. Now I'm going to factor this and solve, and I get this, I'm going to quickly factor it, factors into this. And the solution right here is x equals negative 8. This solution right here is x equals 7. And while it looks like these are both my answers, again, like I said from the beginning, every time you introduce an x squared, you probably introduce an extraneous solution. One of these, and typically it's the negative, but it doesn't always have to be, is going to be extraneous. Here's why. We have 56 minus a negative 8 on this side. And on this side, we have a negative 8 when I replace both x's with the negative 8. And you can see this is the square root of 64, which is equal to 8. It does not equal a negative 8 because you can't have a negative under the radical. So this is an extraneous solution, meaning we have to cross it off. And the other one is going to check out because this here is square root of 49. And that does equal 7, so it checks out, so that is a legit answer. All right, another type of problem. Again, the radicals have been isolated. This one is by itself. This one is by itself. So when we square both sides, what's going to happen? The radical and squared go away. So they are gone. But what we do have right here is a fraction that we need to remove. If we take and multiply everything by 3, or by 3 over 1, we will notice these are going to go away. So we'll multiply this by 3, multiply this by 3. That's going to give us 9p minus 216 is equal to p. And I have just one term of p, so I'm going to subtract the 9p from both sides to isolate it. That's going to give me negative 216 equals 8p. And when I divide by negative 8, so then I'm going to get an answer of 27. Now, I did not introduce an x squared, so I probably don't have an extraneous solution. When I plug in 3 times 27 minus 72 and take the square root of that, so now I have 81 minus 72, which is 9, so I have the square root of 9. And on this side, I have 27 divided by 3, which is also 9, square root of 9. It checks out. Good to go. Okay, last problem. I'd recommend you try this one on your own. So you can pause the video and I'll run through it. Okay, I went through my answers. I got 2 of them. Notice from the beginning I introduced an x squared, meaning I probably have an answer that is an extraneous solution. It is probably the negative, but it doesn't have to be. And you will see it is the negative when I check this, because right here I get the square root of 49, which is equal to 7. It is not equal to negative 7, so that is an extraneous solution. But when I plug in 6, I get the square root of 36, which is equal to 6. That one does check out. So you should get an answer only of x equals 6. And that's it. You can now pull up the assignment 7.5a on online and work on that. And that is due tomorrow when I see you. Have a good day.